Hey, AP Physics 1, this is Horner. We're going to look at number 2000, number 1, and we've modified this problem to make it so that it is very, very similar to an AP Physics 1 problem, even though it's an old AP Physics B problem. We have a cart moving on a horizontal track, so just like we've done in the class, and they're graphing the velocity versus time for this cart, and it's accelerating, it's decelerating, it's doing all kinds of different things as it moves from one place to the other. So they want us to identify some portions of the graph where the cart is at rest. So at rest, we know that that would mean that the velocity has got to be equal to 0. We know the velocity is 0 here, and then it's also 0 from here all the way over to here. So we can go ahead and write those times down. That'll be 6 seconds, and then it will also be 14 through 18 seconds. So if you look at the graph, you can see that that matches up. Next thing they want us to do is look and see when the speed, so remember that's magnitude of the velocity, is increasing. We've said several times that you have to be moving away from 0 in order for it to be increasing. So even though this whole line is sloping down, the speed is only increasing from about 6 seconds here all the way down to 10 seconds. So that's the first one. This is going up, but it's not increasing. You'll notice that the numbers here are getting closer to 0, so it's actually decreasing in speed. But right here, we are increasing in speed again. So our next position time here would be 18 through 21 seconds. For letter C, it says determine the horizontal position of the cart at 18 seconds. If the cart is located at 2 meters at 0 seconds. So let's get rid of some things here. We need to first off recognize that right here, the car is at x is equal to 2 meters, and it's moving at that speed of 1.2 meters per second. Let's break this up into a couple of different areas. So here is the first triangle that we have. We're going to name it number 1. We've got this very big triangle here. This is going to be number 2. And then we just have an area right here, which isn't an area, and it's number 3. So the cart's not moving here, so it doesn't have any distance. I do realize that this is actually 2 triangles, and so we'll treat it that way. Let's look at triangle 1 first. So we want the area of that triangle, so it's going to be the change of position is just the area of the triangle, which would be 1/2 times 6, that would be the base, times the height, which would be 1.2. If you do that math, you get 3.6 meters. So we know traveled 3.6 meters here. Now we've got to figure out what is the area here that it travels. And so now this is going to be for part 2. We're going to say this is 2 because I have 2 triangles times 1/2 times 4 times 4. That would be the width and the height of each triangle. So this 1/2 base times height, we're going to multiply both by 2, and we end up here with 4 meters. So we end up with 4 meters. Now, if you're really good, you've got to recognize that this 4 that I have here, okay, is in the negative direction. So we actually need to make this one negative. If you make that negative, then this is negative. And when you add the two together, we're going to end up with 3.6 minus 4, which is going to be negative 0.4 meters. So that's what this entire thing shows, is we went a distance of negative 0.4 meters. That's our displacement. But we started at 2, so we're going to add that to 2 meters, and we're going to end up with a final position. Okay, so they want to know the position of the cart, and so we're going to take 2 minus 1.4, and we're going to get positive 1.6 meters, and that's our answer for this part. All right, let's go on to the back side of the worksheet. And when we go on to the back side, you'll notice that they want us to make an acceleration versus time graph for this next part. Here we're going to mark off letter E. We don't need to worry about it at all. And we are going to make sure that we get all these right. When we look at our graph here of velocity versus time, we know the slope of this line's acceleration. So let's go ahead and just find these values first. This would be negative 0.8 minus positive 1.2, and we're going to divide that by the time, which is 10 seconds. If I add these together, I'm going to get 2, and 2 over 10 is going to be 0.2, and it's negative meters per second squared. So that's what this one is. This one has the same slope, but it's in the positive direction, so it's positive 0.2. Here we have a slope of 0. Here, let's calculate the slope. It's 1.2 minus 0, which gives us 1.2, and then we divide that by 2, and so, oops, we're actually going to divide it by 3. 1, 2, 3. So we're going to divide it by 3, and we get 0.4, and then this is 0. So we've got all our numbers now. I'm going to put them over here, do them in a nice bright green. So this is negative 0.2, then we have positive 0.2, then we have 0, then we have 0.4, and then we're going to have 0 again. This one goes all the way up to 10 seconds from 0 to 10. This little portion here will go from 10 all the way over to 14. The 0 goes from 14 all the way over to 18. This 0.4 goes from 18 over to 21, so 18 to 21, and then finally at the top we're just going to do 21 all the way over through 25. So now that we have all our points, I'm going to erase all this stuff and go ahead and move to the next part. So I'm going to move this down, and here's our graph. So we know all our slopes and our values. 0 to let's change this. 0 to negative 10 is, 0 to 10 is negative 0.2. And so we're going to move this over here. The next one is 10 to 14. And 10 to 14 is positive 0.2. From 14 to 18, 14, 15, 16, 17, 18, it's 0. Then we've got to move all the way up to 0.4. In 0.4, we're going to do this one from 18 to 21, and then finally from 21 to 25. That one is a whopping 0. So now that we've done those, we should be done with this problem, and that is it.